We are talking about 45, 45, 90 triangles. This is a special kind of right triangle that you see quite a lot. If you take a square and you cut it in half diagonally, you've got a 45, 45, 90 triangle. So if your square is one unit on the side, its diagonal is going to be the square root of 2. These are the ratios in all 45, 45, 90 triangles, 1 to 1 to the square root of 2. So in general, if you know the one side, all the other sides are really easy to get because there's another one side that'll be exactly the same. So let's say this was 10, then this side would also be 10, and this side would be 10 times the square root of 2. Let's look at a couple of problems here. In this one, we've got a 45, 45, 90 triangle. I know that because I've got a right angle here, that's the 90, and I've got a 45 here. That leaves 45 left over. So this is definitely a 45, 45, 90 triangle. And I've got this side. Well, how do I know? How do I keep track of which side is the one side and the square root of 2 side and so forth? Well, the square root of 2 side is always going to be the hypotenuse. So I'm just going to put this square root of 2. Actually, I'm going to put it in parentheses because that's not really the length of it here. That's the ratios I'm using, 1 to 1 to the square root of 2. Now, if the one side is 5, that means the square root of 2 side is going to be 5 times the square root of 2. And that is our answer. X is 5 times the square root of 2. Let's take a look at this one. It says in ABC, A is a right angle, B measure of angle B equals 45. I guess that's going to make it a 45, 45, 90. And then it tells me the length of AB. Sounds like I need a model for this. Let me just sketch one out here. Whoops. So here's my 45, a 45, 90 triangle. It says A is the right angle, and then B is 45, and C is going to be 45 as well. So for my sides, this is the one side, this is the one side, this is the square root of 2 side. It says AB is 12 feet, so that's this side. Aha, so that's pretty easy. That's the one side, so I know this side is going to be 12, and this side is going to be 12 times the square root of 2. It says find AC, so that's this side, so that is going to be 12. So when you know the one side, it's pretty easy. What if you know the square root of 2 side? Like down here, this is our hypotenuse. We can tell that because it's directly across from the 90-degree angle. So we have the square root of 2 side, but we want to find the one side. So let me just sketch in my ratios here. So how do we do that? Well, you might be able to memorize that you can, divide instead of multiply by a square root of 2, but you can always set up a proportion if you're not sure. So setting up a proportion would go like this. I have my world of ratios, that's this world, and then I have my world of real numbers, that's this world. So we're dealing with these two sides. I'm going to say 1 is to the square root of 2 so that's my ratio numbers. Now I just need to put the real world sides in the same order, as x is to 8. Okay, so there's a proportion that's set up correctly. The next step is to cross multiply. So we would get 1 times 8 is 8, and square root of 2 times x. So that's x times the square root of 2. Then to solve for x, we're going to need to divide by the square root of 2. So we get an answer, let me put it over here so I have more room, of x equals 8 over the square root of 2. But having a radical in the denominator is a no-no. So we need to rationalize the denominator. We do that by multiplying by the square root of 2 over the square root of 2. So basically you choose whatever radical is in the denominator of your answer, and you multiply by that over itself. This is a form of the number 1. When we multiply anything by 1, we don't really change it, we just change the form of it. And this works out nicely because on the bottom you get the square root of 2 times the square root of 2. That's just the number 2. And on the top you get 8 times the square root of 2. And that is our answer. So a little trickier when you have the square root of 2 side and you want to find the 1 side. But set up a proportion, cross multiply, and then rationalize the denominator if you have to. So that's a little bit of work with 45, 45, 90 triangles.